Senku Ishigami is staring at his lab shelf. He's got hundreds of ingredients in front of him. Sulfur, charcoal, saltpeter, weird half-decoded chemicals he doesn't have names for yet. He needs to combine two of them to hit a specific target value. Somebody's bleeding out. He has a few minutes to find it. That's two sum. Same exact problem. You've got an array of numbers, you've got a target, and you need to find the two that add up to it. It's the most asked LeetCode problem on the planet. The first one every CS interview throws at you. Because honestly, it sorts the people who actually think from the people who just nest two loops and pray. Quick disclaimer, I'm walking through this with 5 ingredients, not 500, because nobody wants to watch me trace 1,000 iterations. The example is just so you can see it work. And before anyone roasts me in the comments, yeah, the first time I saw this problem I wrote the brute force version. We all did, don't pretend you didn't. We have 5 ingredients, 2, 7, 11, 15 and 5. Our target is 20. The lazy way is brute force. Senku would never.
I will never do such a thing.
He'd be done before we'd even opened our IDE. But let's actually walk through it, because you need to feel how slow this gets. The idea behind brute force is exactly what it sounds like. You don't think, you just try everything. You take the first number and you check it against every other number to see if they add up to the target. If they do, great. If not, move to the second number. Check that against every other number. Then the third, and so on. Eventually you'll find the pair, or you'll have checked every possible combination. No cleverness, just checks every single pair. Take the first element of the array, which is 2. Check it against 7. It's not 20. Check it against 11. Not 20. Check it against 15. Nope. Meanwhile, Senku has already synthesized a brand new compound. Take 7. Check it against 11, 15 and 5. 3 more checks. Still nothing. Senku has now discovered antibiotics. Take 11 against 15 and 5. Nope. Senku has built a working telephone and is on a call with somebody. Take 15 against 5. Finally, 20. We did it. It took 10 comparisons, 4 ingredients, and a small piece of our dignity. Senku is now on his way to Mars. 10 comparisons for 1 pair on a shelf of 5. Whatever, fine with 5, but scale it up. 100 ingredients gets you about 5,000 comparisons. 1,000 gets you 500,000. A million? A trillion. This is 2 nested loops, O of n squared. Okay, here's the actual move. It's called the hash map approach, or as we say in French, le dictionnaire. Senku doesn't walk back and forth across the shelf like a mad scientist looking for a misplaced test tube. He doesn't have time for that. He walks past the shelf once. For every ingredient, he asks one question. The value I'd need to pair with these to hit 20, have I already seen it on the shelf behind me? If yes, he's got his pair. If no, he keeps walking. But now he remembers what he just looked at. Next ingredient, same question, but his memory is 1 item bigger. He's not searching the shelf over and over like a psychopath. He's building a memory and just checking new things against it. That's the whole algorithm. In Python it looks like this. 7 lines, that's it. And before you ask, yeah, dictionaries and hash maps are basically the same thing in Python. Don't stress about the terminology. The thing you actually need to know is instant lookups. You ask the dictionary, yo, is this thing in here? And it tells you immediately. Like Senku looking at his mental inventory and just knowing whether sulfur is on the shelf or not. He doesn't go searching. It's there or it isn't. Let me walk through the algorithm with the same shelf so you can see it tick. First iteration, current is 2. Its complement is 18. The dictionary is empty. Therefore, store 2. Second iteration, current is 7. Its complement is 13. Nope, 13 is not in the dictionary, store 7. Third iteration, current is 11. Its complement is 9. Still nope, store 11. Fourth iteration, 15. Its complement is 5. Not yet, store 15. Fifth iteration, 5. Its complement is 15. Yes, 15 is in the dictionary. Return indices 3 and 4. Done. Boom. We out, baby. 5 iterations. 1 pass. That's O of n. Meanwhile, the brute force version is still on iteration 3 somewhere, sweating, crying, missing its deadline, slowly turning into a memory leak. Here's the part that matters, because this pattern is everywhere. The hash map version isn't doing more work, it's doing less work, smarter. Every ingredient you have already seen is sitting there, instantly findable the moment its complement walks past. You are not searching, you are remembering. And remembering is way cheaper than searching. Memory is cheap, time is expensive. Trade one for the other.
Domain expansion. Outro.